According to NASA, 2020 was the warmest year on record, and by 2030, the temperature could rise by a further 1.5 degrees Celsius. By 2045, 135 million people will have to leave their homes. This leads to extreme poor standards of living and expensive air conditioners for consumers and the planet. Can you imagine yourself living with 42 degrees Celsius or more, with long periods of drought, and without air conditioning? This is how 68.8% of the population lives in La Guajira, Colombia. Thinking about this, we wonder, how does nature deal with this problem? We as a team went to the tropical dry forest, a unique ecosystem in the world that adapts to long periods of summer and short periods of rain. We came across the Anurans strategy to avoid dehydration and keep cool. Anurans have mucus glands in their skin that store and release a substance as a strategy to avoid dehydration and regulate their internal temperature. On the other hand, research shows that tree leaves vary in size and shape depending on their position in the tree's canopy layer system. This organization allows leaves to receive and maximize solar energy, and also allows them to filter the amount of light that reaches the soil. Then we return to the Technological Research Laboratory of Sindhu at the National University of Colombia in order to test the strategies of the organisms of the tropical dry forest of the Caribbean region. We made different scale models in order to measure wind control, sunlight flow, and thermal cooling, using hydroretentive polymers with different organizational patterns and generating heat by an infrared bulb. We concluded that the system could cool the interior temperature by up to 15 degrees Celsius. Following the same functional grid, we sought to create the interaction of plates inspired by the geometry of the age principle of the leaves of trees, thus varying their density according to the user's needs. This is how we came up with HydroCanopy, a low-cost, high-efficiency solution that responds to climatic conditions using passive control strategies that regulate solar radiation, ventilation, thermal and inertia, and offers an evaporative cooling system. It is a system of easy construction and implementation, structured by 3 modular grids with an orthogonal grid of 60 by 60 centimeters, built in guadua and articulated by knots. HydroCanopy responds to the economic and social factor, which is why, in its assembly and maintenance, low-tech technology is chosen, being easy to transport and using materials and techniques known and traditional in the region of La Guajira. HydroCanopy, thermal regulation inspired by nature.